Welcome. So in this part, we're going to be introduced to what the least squares regression line is. So what is the definition of it? It is the line which makes the sum of the squares of the residuals as small as possible. Now, if you're reading that and thinking, what on earth does that mean? Do not worry, because we're going to jump straight into a visual to help us understand it. And you might like to pop this visual into your notes. So here it is right here. So let's break this down. So as you can see, we have y, which is our response variable. We have x, which is our explanatory variable. And these purple dots are our data values. And then we have our least square regression line here in blue. Now, the residual is the vertical distance, so this right here, between the data point and the line. So the residual is the vertical distance between the data point and the line. And the residual can either be positive, that's when the data point is above the line, and it can be negative, that's when the data point is below the line. Now, the least square regression line is an accurate line of best fit through all of these data points. And what makes it accurate is that the sum of all the residuals is as small as possible. So the sum, so when you add together all of these residual values, that value is as small as possible. And you can kind of picture in your head how this makes sense. If the residuals are as small as possible, this line is going to be very accurate. Now, at the moment, if you were to add up all the residuals, because some are positive and some are negative, what's going to happen is the positives and negatives are going to cancel out. And that's a big issue. So how can we prevent the positives and negatives from canceling out with one another? Well, what we can do is we can square everything. So we can square all the residual values. Let's imagine for a moment that this here is -3. Well, if we square it, we get +9. Because remember, whenever you square a negative, it becomes a positive, because a negative times a negative is a positive. So before we add them together, what we're first going to do is we're going to square all the residuals, and then the sum of the square is going to be as small as possible in order to make this as accurate as possible. And now, if we come up here and we read our definition again, hopefully it makes a little bit more sense. So let's read it again here. It says, the line which makes the sum of the squares of the residuals as small as possible, in which a residual is the vertical, let me move this a bit, in which the residuals is the vertical distance from the actual point to the regression line, that is the predicted line. And hopefully with this definition now in our heads, just the name of this thing makes a bit more sense. Least, because we want the residuals to be as small as possible. So that's where we get the word least. Squares, because we're squaring everything. And then regression line, because it's a line going through it. So that's why we call it the least squares regression line, because it's the line which makes the sum, which is adding, of the squares, when you square something, of the residuals, which is that vertical distance between the data point and the line, as small as possible. I know it's a bit of a mouthful. Don't stress too much if you're still a bit shaky on all of this. We're going to go through more examples. And also, for our understanding, the CAS is going to do all the heavy lifting. So even if we don't have a great, robust understanding of this, the CAS will do most of the heavy lifting for us when getting these lines. But I still think it's very important to understand this definition as best as you can, because it makes sense out of the name of it. Okay, I'm going to pause here and then we'll continue on with the notes.